Okay, so here I'm going to try to make a quick video to try to explain how I think the whole Stanley Meyer circuit works like. So let's start from the beginning. Here's the VIC coil and transformer, and it works like this. Here you have the positive variable input, a diode, and then you need a capacitor to handle the kickback from the primary. And we're going to do it in this way. Here we have the primary coil, and it has a diode here and a TVS diode for, let's say, 800 volts, or a resistor or whatever, just to hold the spike to not burn to prevent burning the IGBT. Then we have another coil, just the same size as the primary coil, and this is going to have a diode connected to the ground, and it's going to be connected also to the positive side. So when the IGBT cuts off the current, this coil reverses the voltage and kind of discharges the excess energy back into this capacitor. So it's going to be used on the next cycle. That said, let's go to the VIC part, the voltage intensifier circuit part. It's nothing other than a pulse forming network. Actually, it works like this. This is the secondary coil, and this is the diode, and this, I will explain why this diode is here and not here. Okay, this diode, and this is the infamous choke. Okay, here we have it can be made of stainless steel wire or whatever, and I will explain why. This coil must be wound preferably in sequence of the last layer of the secondary coil, and it don't need to be large enough. It don't need to be very large, because what's important mostly is this capacitance here. So it could also be a bifilar coil, for example. You can test it wherever way you want. But the important is that the capacitance across this diode, plus this capacitance of this pulse forming network, plus you can put another diode at the end here with another capacitance. And what's going to happen is that when you pulse it positive, let's say we have the dots like this. You put a positive pulse here, and you're going to have this part positive, this part negative. So it's going to sum up this voltage of this capacitance to this coil to get a kind of voltage multiplier effect. It's even greater than doubler. You can connect, for example, a capacitor here, and you pulse it, and you're going to see that it's going to charge to a much higher voltage than this voltage turns ratio, because every time the pulse turn off, this pulse forming network will charge back to the capacitance voltage. So it's going to charge from that reference and keep going. That's why it forms very high voltage from very few coils. And now let's come to the very interesting part, that is the cell, and how I think this bifilar coil must help us. Okay, let's consider we have the cell and we have a bifilar coil wound around it. okay? And it can be like, it's not here, but okay, it can be like a speaker wire, for example, wired all over around the coil, the cell. And then you have the ends of the coil connected to the cell. Across one of at least one of these coils, we can have a resonant capacitor, okay? And what's going to happen here? As we pulse here at a dynamic voltage output that's going to be ever increasing according to the voltage we have across these ends of the pulse forming network. And this resonant capacitor is going to form a very high voltage here. It can form, for example, thousands of volts. So the cell and the VIC coil are isolated, let's say isolated ground. And why it's isolated ground here? Because we are going to want to kind of have an ability to test the cell's voltage, right? So actually this high voltage it doesn't matter for now. It's just for having the high voltage and excuse me, the high magnetic field oscillating here that is necessary for the system to work. But actually the function of this bifilar coil is to balance the voltage such a way that we get a possibility to measure only the interesting current here. For example, the pulse forming network will have a charging current that will never exit this circle. For example, you put a positive here, blah, 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 and then it's going to charge up. Of course, it's going to charge this capacitance through this, let's say, closed circuit, this end up of the capacitance, okay? But actually, you're charging up also from here, okay? So all this current is closed in this circle. And with that in mind, you get that also all this resonant current is also closed in this circle, in this coil, okay? So once it's charged, let's say the current to keeping it charged should be very, very small, okay? So the circuit is going to keep applying voltage here, and more voltage, but it's all unconnected. Let's say here we have 0 volt, except for the DC voltage we are putting here, and that's going to end up in the water gap. All this resonant voltage here is going to be 0 here, because the bifilar coil is equal in length and turns, and the coil's capacitance should filter all this and keep 0 here. Why is that so important? Because when water starts to develop a voltage here, what's going to happen? This voltage is going to start to charge back the pulse forming network to its voltage level, okay? So I get that we are going to have a current that's going to be charging, and this is going to be coming back in that direction. So why is that important? Because the point here is that we may, with this is insulated, with this also feedback resistor connected to the feedback transformer, all insulated. All this high voltage is also insulated because all two electrodes are supposedly at the same high voltage common mode. What we can do, we can put here inside the water, let's say a grounded sensor. That's going to be easier to do for now. Why I'm saying this? Because we get I got the piezo sensor to work with water, but in this case, if for example we ground it here, or for example we ground it here to get the current feedback, what's going to happen? Water is going to be at high voltage. This is inside of, for example, acrylic, so water is going to be at high voltage. So how we get along with that? We get this part fully insulated, and then we ground another point in water far from the electrode where it's going to be placed the sensor. So we get the possibility to get the feedback of the up and down movement that's going to be caused by the helical structure we get inside the cell. Who is following me should be aware of it by now. So what's the point? What's the end? How it works in the end? So we get the pulse forming network sending a high voltage pulse that charges up this resonant tank, and this voltage is applied to the water right here. It's in sync with the oscillating magnetic field. And what that's going to make? That's going to make a force up and downwards on the water, just like a motor. But as we have an oscillating magnetic field, this make a DC current, and this is going to make a force in one direction. And this is a restoring force. So we are going to get an oscillation in this inside a cavity. Let's say this is inside a cavity, a tube, whatever. And so we're going to have like this is becoming a transducer. And we actually want to work it at this anti-resonant point where it's going to have the maximum energy accumulated into it and maximum impedance input, so that we restrict the infamous amps and allow the voltage to take over. And all this is going to make the cell have a kind of voltage output like this, because let's say we are getting this pulse in, but then we are going to start to get, the pulse coming from the water coming back in the other direction. Because if we put force in one direction with the magnetic field in one direction, it's going to make a electromagnetic force in the same direction. And then when it's restoring force is acting upon the water molecules, making it change direction, going the other direction, we have the magnetic field in the other direction. That's why we generate another pulse of the same polarity. You see? I know it's kind of harder to understand, but it works just like a synchronous DC generator. brushless DC generator. You flip the magnetic field at the same time the coil is passing again through the magnetic field. It's the same thing. So the video is getting a little longer, a little too long, and I think I have reached all the basic information I wanted to pass here. So what's important is that this resonant frequency matches this resonant frequency. Otherwise, we are not going to have this perfect waveform. And that's why this sensor is so important, because we are probably going to lock this input frequency to this sensor, because this is going to get this wave and get the perfect, let's say, feedback for our readings. I'm guessing that we can, once this is working very well, this back current coming in this resistor to charge back the pulse forming network may be enough feedback so that we know this frequency that's going to be generated here. So we kind of maybe have a possibility that we don't need this in the future, but I guess for now, to study and get the things working, it's absolutely necessary. And with the previous video of the feedback circuit, we can use being electrical or this, whatever is going to work with that circuit. So that's it for now. Wish you good luck. Hope you wish me good luck too.